Welcome to solverfy.
We are asked to prove that the number of partitions of an integer n is the power of x to the n in the formal power series expansion of 1 over 1 minus x times 1 minus x squared times 1 minus x cubed, and so on. To do this, let n be an integer, a positive integer. Well, we have that in a partition of n, we can include at least 0 ones and up to n ones. And in fact, if we don't put a restriction on the top, we have that the generating function corresponding to 1 will be including every power of x divisible by 1. So this is going to be 1 plus x squared, and so on. Likewise, the number of 2's in the partition, well, there has to be at least 0 2's. So we start at 1. And there can be as many 2's as up to n over 2, but if we don't put a restriction, we have that we can only form even numbers out of 2. So it follows that in the generating function for the 2's, we're only including the powers of x divisible by 2. So 1, x squared, x to the 4th, and so on. Likewise, for 3's, we have 1 plus x cubed plus x to the 6th, and so on. And so if we continue this process, finding a generating function in this way for every natural number, so that in general k is going to be 1 plus x to the k plus x to the 2k, and so on. And we have the total generating function is going to be 1, generating function for 1's, which is 1 plus x squared, and so on, plus the generating functions, or multiplied by the generating functions for 2's, so 1 plus x squared plus x to the 4th, and so on, times the generating function for 3's, 1 plus x cubed plus x to the 6th, and so on. And this keeps going on. And we have, by a theorem from the book, that this is going to be equal to 1 over 1 minus x times 1 over 1 minus x squared times 1 over 1 minus x cubed, and so on, so that we get that this generating function is 1 over 1 minus x times 1 minus x squared times 1 minus x cubed, and so on. And we have that in the formal expansion of this generating function, the coefficient of x to the n is going to be the number of partitions of n. And so it follows that p of n is the coefficient of x to the n.